We can graphically represent our objects, for example, vectors, using generic plot types included in R, such as plots, histogram, box plot, sometimes called box and whisker plot, bar plot, and pie chart. Let's look at an example. Suppose we create a vector called K with the following numeric values. Let's go ahead and create that. We'll appear here. We have the objects created here, numeric values from 1 to 6. You can simply use the XY plot, pass our object, execute that, and on this label plots, the data points will be plotted in our chart here. Okay. So from here, we can see it's very bland. We can enhance this a little bit by adding some more arguments in our plot function here. So to do that, separate that by a comma. We type main. Main just means we can include a string or character or title for main over here. Okay. XLab means the x-axis, right? We give some meaningful label. Okay. We give that index. Then ylab here for the y-axis. Then the type here means what type of line, or rather the type here means we're going to use a line to draw and connect the points. Then lastly here, color means, we can give it some color. And then LWD means the line width we give it to. So we execute this. You can see here, we've already drawn the points, connect the points using a line, and that's the line width. If I change that to 3, you can see the line width changes. Okay. Again, here we're using numeric here. I could as well just type here blue. We'll achieve the same result. Okay. For more information about the plot, you can just type $plot, and you can see here you can click on the generic XY plot like here before. Okay. And then from here you can read more about the different arguments you can use. Okay. So let's look at an example for histogram. I can just clear this for now. Control L to clear that. Then we generate a random number from a normally distributed normal distribution, right? So we create that. We can actually see it's quite a bit. If I type there K, you can see all these are randomly generated numbers from a normal distribution. Okay, we can plot that on a histogram. All these are data points. Okay, so histogram is a data reduction technique. So on this again, we can improve this a little bit. It takes 2 arguments. So we can say we want to represent this as an index or rather density, right? Then we break here, give some break of maybe 40. Okay. So if I run that, you can see now the spacing here has changed. So this is a number to help you just fine tune. If I do maybe 10, the width will increase, right? So if I do 50, okay, you can see the width here kind of changes also. Okay, so a great way to visualize your data points, especially if you're dealing with hundreds or thousands of numbers. Histogram is a very good technique to reduce that. Box plot, again, let's create another vector here. Notice how we're just adding 3 to a random number of 500 and raised to the power of 2. Just another complicated number, but we can do that. Hey, why not? So create that, and we can create a box plot. Okay. So here it takes an argument, right? This just the color. If I change this to 3, maybe it will be another color, right? And I could change this maybe to 1000. Okay. Or probably 1000 here. Okay. There already we can see that based on the 5-number summary. So at the bottom here is the minimum number. If we run summary here, it's a bit descriptive. You can see, so the minimum here is this value here. Let me just use this. This would be more descriptive. So here we see we have the minimum. This is the median, right? And then Q1 at the bottom of the box here, and then at the top here, this is Q3, then here's the max, right? Then if you calculate the 1.5 of the IQR, anything above that, we consider that as an outlier. Okay. Okay, so that's just that. We can also represent, create a barplot. So just create this vector here. So let's say these are just populations of the different states. Okay, so I just summarized this to be 40 million, 20 million, 14 million, maybe 1.4, 14 million, 12 million. So we can represent this in a bar chart as well, bar plot. So let's go ahead and create that and represent that. So we can see we have a nice representation. So we can also improve this, remember, we can just type main. Okay, so main there, you can just say, okay, this will be population. Population. Okay. Then we can also say here the X lab, which means it's just the labs here, or rather the X labels, right? We could just say here states, right? For Y-axis, just type Y lab. Okay. We could just say population here, right? Population. Remember, these are strings, right? Population. Okay. Here we could give it a meaningful, let's just say title for now. Okay. All right. And then also we can say color, right? So color, call, we call it call. Then we can say we want to give different colors. So we can say C, we could say 1, 2, 3, 4, 5, right? We have 1, 2, 3, 4, 5, and 6. So you can just put there 6. Okay. I run this again. You can see we've introduced some color for each of these bar chart, put some label for X and Y axis, and also we put here some title. All right, and that's the end. That concludes our video on plots.